on this computer. I nearly forgot about that. Okay, you still can't. Okay, what I'm going to do is hoping that wasn't going to cause any problems again. I enabled everyone. I'm going to make you the host, and you should be able to have control over your video.
Okay.
Spotlight everyone. Pass to start video.
No, it's still giving me an error.
Okay. Only ones are going to do that. Okay, I'm going to make you the host. And you can just give it back to me after.
Okay.
So on the panelists, do you see the panelist view here, like all three of us?
Yeah.
Okay, so you can right click it and make me the host eventually. So I'll make you the host and you should have control over it.
Oh, there we go.
All right, perfect.
Okay, you can just see the PowerPoint?
Yes, I can.
Okay. So yeah, I'm doing the beginner session and I'm going to be doing it on the moon because I think it's a great beginner's object and it's kind of overlooked. So the moon can sometimes be overlooked as a target of observation because it's so constant and it's not as glamorous as planetary or deep sky objects. But I think that there are a lot of good reasons to observe the moon. First, because of its proximity to Earth, we can observe so much more of the moon than any other astronomical object. We're quite lucky to have such a large natural satellite. It's actually unusual for satellites to be so large relative to the size of the planets they orbit, but we get to see so much of it that we can pick up thousands of details. So you can see in the top image, that's a scale image of the size of the Earth and the moon and the distance. So I was shocked to see that image, but it actually, that is quite a large satellite, the moon there. While it's easy enough to find, even for beginners, the moon is wonderful for all levels, with many details that can continue to excite and challenge even the most seasoned observers. It never quite looks the same from night to night, but our cosmic neighbor, it's the closest cosmic neighbor. We know more about it than any other astronomical object other than the Earth, and informing ourselves about it can really enhance the experience. Its luminosity might be an annoyance when trying to observe other objects, but it makes it very easy to find, even in cities when light pollution is very difficult. So that's why it's a good object to start with. So I'll start by talking about kind of what we can see. We see the near side of the moon. It's in synchronous rotation with the Earth, so the near side is actually always the same side of the moon. This is also known as being tidally locked. However, libration or libration also allows us to see slightly more than half of the lunar surface, so about 59% over a period of time, as you can see from the time-lapse video. I believe that was over the course of a month. It's just one lunar phase cycle. Libration is the wavering of the moon from our perspective. So due to the eccentricity of the moon's orbit, the moon kind of shifts in longitude, and the moon also has a slight inclination of about 6.7 degrees from the plane of its orbit. So we also see a bit more that way. Talking about the phases, as we know, different parts of the moon are highlighted by the sun as the moon orbits and rotates around the Earth. This causes the different phases of the moon, and the time it takes for it to return to the same phase is known as the synodic month, a period of about 29 and a half days, almost matching up with our months. The most recognizable of these phases are the new moon and the full moon, obviously. They are about I guess, 14 and a half days apart. And the period after the full moon, as it in the transition from the new to the full moon, is distinguished as waxing, and the period after the full moon, as it gets closer to the new moon, is called waning. It's pretty easy to remember if you think of it as the moon slowly disappearing day by day as it wanes, and then waxing is just the opposite. New and full moon are only two of the principal phases. There is also the first quarter and the last quarter, or the third or final quarter. If you consider the moon to be the beginning of the phase, or the new moon to be the beginning of the phase cycle, then the first quarter comes next, so it's still a waxing moon, then the full moon, then the last quarter in the waning period of the cycle before returning to the full moon. Half of the moon is illuminated by the sun at any given time, but during these phases, we only see half of the illuminated part, so that's a quarter, but it's also just a quarter of the way through the lunar phase. So that's where it gets its name. Filling in the time between the principal phases, we have the intermediate phases when we describe the moon as either crescent or gibbous. As you can imagine, the crescent is distinct for its concave shape, making it look kind of like horns, depending on the orientation. Logically, the crescent happens between the new moon and the first quarter, and then also between the last quarter and the new moon. Gibbous is distinguished by its convex shape along the terminator. This is where the illuminated hemisphere meets the dark hemisphere. The moon is in gibbous between first quarter and full moon, and also between the full moon and the last quarter. Crescents and gibbuses are also labeled as waxing and waning, depending on which quarter of the cycle they are in. If we put all this together, then starting with the new moon, we see a waxing crescent followed by the first quarter, then waxing gibbous, full moon, waning gibbous, last quarter, and finally the waning crescent before the new moon, and the cycle starts all over again. If you're doing a certificate such as the Explore the Universe, it's important to know that the moon is in certain phases at exact times, and one has to observe them within a time frame for it to count as the full moon, first quarter or last quarter. And if you've bought the RASC calendar, it'll tell you exactly what time when the moon is in a certain phase. Perfect plug, because it's coming out soon, I think. It's also helpful to know what time the moon rises. Whether you're trying to observe it or avoid it, doesn't matter. It's still useful information. The Observer's Handbook has a chart of the moon rise and moon set times for the whole year. As long as you know your latitude and the time difference from Greenwich, as well as the date, of course, you can find out the perfect time to observe. Ooh, there we go. There are many ways to observe the moon. My personal favorite is just to look at it naked eye and take it in, but there are still many things to observe about the moon naked eye beyond just its path across the sky and its different phases. As I mentioned, libration is also interesting to observe. Oh no. What is this? Okay. Can you guys see that again?
Yes, we can.
Okay. Libration is also interesting to observe and makes for some really neat time lapses. Since the moon's orbit is off from the ecliptic by about 5 degrees, it occasionally occurs that the moon has close encounters with other solar system objects, at least from our perspective, such as eclipses, both lunar and solar, are always exciting to observe. The moon's part in the Earth, moon, and sun system. The moon is frequently in conjunction with bright stars or even planets as it makes its way across the sky. When the moon passes in front of other stars, that's called a lunar occultation. The Observer's Handbook has some information on lunar occultations and a list of occultation predictions for the whole year, organized by locations across Canada and the United States. And Winnipeg is one of those locations. So we have a neat little list there. Earthshine is another phenomenon to observe that gives us a literal view of the actual dark side of the moon and a new way to photograph and observe the moon's features. Also, you can sometimes notice neat atmospheric effects that add another unique observing opportunity and can extend interest in lunar observing. For example, literal blue moons can occur when smoke or dust particles are abundant in the atmosphere because of dust storms or forest fires. as was the case in Sweden and Canada in 1950 and 1951, or due to volcanic eruptions like the eruption of Krakatoa in 1883, which made for green sunsets and gave the moon a slightly bluish tint for nearly 2 years. That would have been really cool. But if you are, oh my God, what is this? Sorry, I'm using my university software, so it's acting up. But anyways, if you do decide to use binoculars or telescopes or cameras, then there are over 1,000 features to hunt for, and many of them can be seen by amateur telescopes. So it's a good idea to start with a map of the lunar surface to help you find your way around the features or identify what you're looking at. Unfortunately, it's a bit more complicated than just picking up any map. If you are using binoculars, then you'll see the moon as you would naked eye, with the north side up and the south at the bottom. That's no problem. However, depending on your telescope, the mirrors may flip the image to be either reversed east-west or inverted north-south. Some telescopes even do both. Sometimes you can just turn the map upside down to match what you see through your lens, but sometimes you might have to do a kind of a mental flip to find your way around. Sky and Telescope offers a lunar map, so I've heard. I'm too cheap to buy it. It's available in mirror reversed and normal versions for a price. It's nice because it's laminated, but you can also find maps online as well. And if nothing else works, some quick image manipulation software can usually do the trick. It's tempting to really try to use all the power built into your telescope to try to pick up as much detail of the moon as possible, like trying to find the remnants of the Apollo visits, which you'll never do unless you actually visit the moon. But you don't want too much power or you'll have a very shaky experience. Additionally, higher powers really emphasize the turbulence in the atmosphere and just don't get the results that you're hoping for. So binoculars and a small telescope are usually enough to keep you pretty satisfied for a while, at least in my experience. It's also a good idea to use a moon filter to reduce the glare, since the moon has a very reflective surface and can quickly strain your eyes. So you'll want to do that, especially during the full moon. If you do decide to take a closer look, the surface of the moon is actually kind of like a time capsule. It's covered in impact craters from the earlier bombardment period of the solar system. Without wind, rain, or other forces that rotorweight the landscape like they do on Earth, most of what we see was actually formed billions of years ago. The darker areas are easily distinguished with the naked eye, but contain a lot of detail when peered at through a lens, though they are often given names prefaced by Oceanus or Mare, meaning sea. Since they were once believed to contain water, they are in fact impact basins that were filled with lava during ancient volcanic eruptions. So it's been billions of years since the moon's volcanoes were active and the lava flows hardened into basaltic rock, which is not as reflective as the lighter highlands. And the highlands are the kind of the whiter areas. So it causes quite a contrast between the dark and the light areas. While these features remain virtually unchanged over time, the sun's illumination of the moon can really bring out the different features in different phases, which makes the moon really a joy to observe, especially when not full. Some of the most awe-inspiring views of the craters that I have seen have been when observing along the Terminator, which is kind of like the sunrise area. That's when the crater walls are particularly or are partially highlighted and contrast against the night side of the moon. This is my favorite way of observing the details on the lunar surface. Sometimes you can pick out really high features, getting some sun before the rest of the surrounding landscape. Like in the top left image, you can pick out kind of a little mountain peak that is illuminated in the dark area of the moon. Aside from the Maria and the craters, you can pick out other features, casting long shadows on the floors of the relatively flat lunar plains. You can see in the bottom image that jagged line, that's a fault. You can also see wrinkle edges and bright rays of the large Tycho crater. And those are kind of like little treasures hiding in plain sight, but it makes it much more than just what you see from the naked eye. Above all, whether you're giving the moon constant attention for a while, just to get started, or return to it every once in a while, it has a lot to offer astronomers of all skill levels. If you're looking to get started, I highly recommend doing some light reading or just leafing through the moon section in the Observer's Handbook. It's only 30 to 40 pages usually, but even more astonishing, more than half of that is just charts for like the moonrise and the moonset or lunar occultations. So it's not even 30 to 40 pages of straight reading, but I really recommend that you guys take your time observing the moon if you haven't already, and you might be surprised by what it has to offer. Thank you. I don't know if we can do questions. I haven't been on other questions in the chat or something.
Sorry, yeah, we can do questions. Does anyone have any questions out there? I guess not. Okay, there's a number of different ways we can ask questions here. But anyways, if you don't mind, you'll just transfer the host to me and I'll do my presentation here.
Sure. I would just like to point out, I think Mike Karakis was talking about
yeah,
an atlas in the notes. So yeah, there's lots of good resources there. All right, you might need to walk me through this. So I just
right click it and
okay. It says you're the host now.
Okay, great. All right. Still waiting for a few panelists here. Well, I'll start with mine. So far, I think Mark Scott won't be able to come. Something has come up, so he won't be able to do what's on with the planetarium. Okay, so we'll start with my presentation. And here, oops, this time I'm not going to do it. Share screen, and here. Okay. And just hit that. Okay, so everyone can see that, Michelle?
Yes.
Okay, great. All right, so we'll make, I'll make my presentation here. So this is the lineup that we have for tonight. James Edward is here. He's the editor of the handbook and journal production, so he'll give us a little bit of insight on that. Scott won't be able to do what's on with the planetarium, so I'll cover for him. There's just a couple of slides, and Jay will do what's up. All right. So, okay, the observatory or the observer's calendar is out. I know the original post said there's 3 people, but it's actually only Abdul and Jay will have the calendars. It's $15. Unfortunately, because of the COVID-19, you're gonna have to stop by at their house. The cost is $15. And just pick it up. We only have limited about 50 calendars, I believe. So please pick yours up quite quickly. Okay, of course, U of M is still closed and will be closed well into the next few years. I asked Danielle if there was any updates, so there's nothing for updates at the university, no events going on as far as I know. Okay, Old Comic Marsh is coming up next Thursday, but unfortunately it is sold out. Space is limited to 25 people. I heard last time they had to refuse some people. Because space is limited, it's only 25 people. All right, Facebook. I know a lot of people are using Facebook now, especially our group here. A lot of people are posting their pictures. It's a great way to see the pictures, and it stays up there. We also do have the forum for the club as well. So yeah, Facebook is quite active. Astro sketching. I know Sylvia is still working on this. She did send an invite last time, canceling it because of the clouds. It's still on as far as I know. She hasn't said anything. So you will get the notice. If you have any questions or if you want to join in, please do. Just send her an email or maybe on the forum too. There is on the forum about it. So if you want to be put on a list, and she'll let you know the next time around that we have the astro sketching. Star party pictures. I kind of mentioned this last time, but I didn't have my slides going for some reason. I will have these pictures posted. I didn't have enough time. I was looking for, there's a lot of behind scenes I have to do. I had a meeting with the National last time. So we're trying to work with outreach right now. We're trying to get that going. And we're also trying to share ideas about what we do for COVID, what different centers are doing. So that's something I'm actively doing with the group right now. So anyways, I'll have those pictures posted soon. Glenley Observatory, those are new. Yes, we do have it. If you want to get the keys, please come see me or on the forum too. I think there's an announcement. There's also my telephone number too somewhere, or my email. I'll post that really soon. I was thinking of doing a members night this weekend. Because of Thanksgiving, I decided just to postpone it, and maybe sometime next week I'll have it, depending upon the weather. Hopefully we'll have it. Of course, right after this, hopefully around 9 o'clock, we'll have our virtual Boston Pizza. This is a meeting, not a webinar. So you're more than welcome to share your ideas, talk it out. Everyone's open. And of course, you can share your screen. All right, I do have make one announcement here. I don't see Sheila's with us. So Sheila has 2 certificates that was awarded to her a couple weeks ago. Astro Imaging, Wide Field Certificate, and Deep Sky Astro Certificate. Apparently, it took her 10 years to get this. And it took a couple more months because of COVID-19, because I couldn't present the award sooner because of the COVID-19. I do have a picture accepting it, and she was really excited to get it. That's her. There's her 2 certificates. So she was really happy. It took, like I said, 10 years for her. That's quite an accomplishment for her. That's me trying to maintain my distance when I presented the award. Anyways, okay, so that's it for my announcements. So happy Thanksgiving for everyone. And we'll stop here. Okay, so far, looks like Jay can't make it. All right, what do we have next? Okay, so I'll just do a quick announcement. Actually, we'll do
a question too.
Yeah, go ahead.
No, in the Q&A, there's a question.
Where is it? Right here. Bill on chat line. Phil Gardner to everyone. What is the liberation?
That's the libration, like the moon phenomenon.
Do you want to answer that?
I can try. I'm not very eloquent unless it's typed out in front of me. But
here, I'm going to answer if you can answer live. Okay, so I'm going to try here.
Okay.
Philip, are you there?
I don't know. I can just try and answer it anyway.
Okay, go ahead.
It's just basically the way that the moon shifts. So we don't actually just see one, like 50% of the moon's surface all the time. We see kind of, we can see a bit north and south depending on kind of the libration, or I mean, you could probably call it a wobble as well. And that's just defined by, you can also see it like east west as well. You can see a little bit past on the east and a little bit past on the west sometimes. And that's just because of the moon's orbit. It sometimes leans a little bit towards us and sometimes leans a little bit away from us, like the pole does. And also due to what was it that the eccentricity of the moon's orbit, we also get a bit of libration along the longitude, and the moon sometimes moves a bit faster and slower. Some kind of eloquent explanation. There's a lot of actual good information on there, but it's actually quite interesting. But I hope that answers your question.
All right, well, thank you, Tara. Okay, so I'm going to move on to is it here? What's on? I lost my mouse here. Where is it? Okay, is it? Okay, point there. Okay, there we go. All right, we'll start with, we'll talk a little bit about what's on with the planetarium. Scott unfortunately couldn't make it, and it looks like a few other people weren't able to make it too. Enable it. Okay, so what's on with the planetarium? Okay, so there's a number of programs that the planetarium has on. It's only through Sunday, from Thursday to Sunday, and 1:30 and 3 p.m. Of course, we have the Manitoba Skies, Search for Life, and Life in the Cosmos. So that's what the shows are. It's limited, but Scott has mentioned that half the funding comes from tickets. So probably be a good idea to maybe check out one of these shows. What else did he have here? I also saw something about telescope workshops. So he's got a little workshop choosing your first telescopes. And if you have any questions about it, I don't know if he's still offering it. One time he did offer about navigating the skies, but that was a fee involved. It was a 6-week course, I believe, every Wednesday. It was quite nice. You get to sit in the planetarium, but with the COVID-19, I don't know how that's working out. So anyways, that's it. That's all I can say for what's on with the planetarium. Looks like we've got some more questions. Philip says, thank you, Tara. Okay, so we're going to stop right there. All right. So Michelle, do you want to start on what's new in the world of astronomy?
Okay, 1 second here. If I can start, let's see if I can, whoops, grab the screen. Yeah, it says host this.
Okay, I'm going to make you host in. I don't know why it's doing that, because when I set this up, every video was supposed to be enabled. Okay, now you're the host, so you should be able to have control over the screen.
Okay. Like. Can you see my slide?
Yes, we can.
Okay, so, right, so let's get started. So you're seeing here is just a thing I kind of slapped together. It's a gravitational wave, and it kind of shows the effect of the wave on the Earth. Bring this up because, there we go. So I've talked a bit about gravity and how it bends light quite a couple of times. And here's sort of just an animation showing that there's a very large mass here and the light is being bent around. And you get this gravitational lensing effect from the light. Well, it turns out that gravitational waves themselves can also be affected by light. So what happens in that process is the gravitational wave coming from some event such as a black hole merger. Just one sec, yeah, such as a black hole merger, that can, if that goes around a massive body, that's going to cause some bending. It also distorts the shape of the wave. So the LIGO's gravitational wave telescope measures those through laser interferometry. I have this little tiny video that I'm going to show next just to give you an idea of how the whole thing is put together in terms of detecting gravitational waves. That being said, this type of work to try and detect, say, distortions within the wave and the signal itself is going to be a lot more harder work. And basically right now, the sensitivity of LIGOs and Virgo gravitational wave detectors are to within 1/1000th of an atomic nucleus. That's how much they feel have to be sensitive to pick up gravitational waves. That's how weak they are. So this is even going to require higher sensitivity to get those subtle deviations in the signal and the shape. So I'm just going to play this quick video. Let me know if you can hear it. Something's not working here. There we go. It's being stubborn. Can people hear that?
This is the sound of two black holes colliding and merging. Where did this sound come from? A long time ago, in the distant reaches of the universe, two black holes, each about 30 times as massive as our sun, were locked in orbit and spiraling in towards each other. The only visible traces of the spinning cataclysm would have been the way their gravitational fields warped the light of distant stars. Even as they collided and merged, there wasn't a flicker of light to be seen. The real and very violent action in the system was in the form of gravitational waves, ripples in the very fabric of space and time. These waves were constantly draining energy from the black hole orbits, leading to their ultimate collision and merger to form a single black hole. At that instant, the power of the gravitational waves was 50 times greater than that of all the stars in the universe combined. That pulse of gravitational waves, lasting only a fraction of a second, expanded through the universe, passing unimpeded through countless galaxies. About 1.3 billion years later, it reached Earth. Gravitational waves alternately stretch and squeeze space itself and everything they pass through, but the effect is minuscule. Their effect on Earth here has been vastly exaggerated to help visualize something that is otherwise invisible on this scale. To detect them and directly measure their properties, scientists built LIGO, the most sensitive measuring device ever made. LIGO uses a device known as an interferometer to measure the tiny displacements in space. In this simplified representation, a laser beam is sent towards a partially reflecting mirror and split along two paths. The beams travel along the 4-kilometer arms and reflect back towards the central mirror, which recombines them, directing their light to a detector. As the gravitational waves pass, the distance between the central beam splitter and the end mirror stretches along one arm and compresses along the other. This changes the time it takes the light to travel along the arms. The recombined light waves shift with respect to one another and produce a signal at the detector. Incredibly tiny stretching and squeezing of space can actually be measured directly in this way. How little does space distort to make this signal? Let's zoom into a hydrogen atom until we reach the proton at its core. LIGO is so sensitive it can measure changes in distance as tiny as 1,000th the diameter of a proton. And this tiny measurement, made by LIGO, was the final step in a journey that began 1.3 billion years ago in the distant universe when two black holes collided.
Okay, so at the end of the video, you could see the distinctive chirp signature. When you downshift it into audible frequencies, it sounds like a chirp when the two black holes circle each other and then all of a sudden just chirp to produce this sort of clapping sound, I guess you could call it almost, but not quite. Okay, so on to the next thing. NASA released recent view by TESS of the northern sky. Now, TESS is a transiting exoplanet survey satellite. So it's designed to search for planets. And in this particular case, trying to remember the name of the previous mission. For some reason, it slipped my mind. But in this particular case, TESS is more sensitive to Earth-size and Jupiter-size planets. And it's completed its primary mission, of which it's confirmed 74 exoplanets and is awaiting 1,200 more, are awaiting confirmation. So some of the, it also has a panoramic view of the southern hemisphere and has over 30,000 full science images. And now it's moving on to re-image missing gaps in the southern hemisphere. TESS also does secondary science, such as a black hole destroying a star, outbursts from a comet, and so forth. So I'm just going to give a video here.
2019, for the very first time, NASA's TESS saw a black hole destroy a star. This was a tidal disruption event, which occurs when a star passes too close to a black hole. Extreme gravity causes the star to bulge and break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the All-Sky Automated Survey for Supernovae, which first identified it, happened in the TESS Continuous Viewing Zone. TESS's 4 cameras scan large sectors of the sky, and one constantly monitored this region for a full year. TESS saw Assassin 19BT as soon as it started to brighten, days before other observatories spotted it. NASA's SWIFT satellite quickly observed the outburst in visible light, UV, and, along with the European XMM Newton satellite, X-rays. The UV measurements are the earliest recorded for a tidal disruption to date. They showed the event's temperature dropped almost 50% in just a few days. Such a steep decrease has never been seen in a tidal disruption before. These outbursts are rare, happening only once every 10,000 to 100,000 years in a galaxy like our own. Future discoveries will help us learn even more about these uncommon cosmic blasts.
Okay, so yeah, TESS, although it is used for primarily for discovering exoplanets, obviously because of its full sky imaging and constant monitoring, is also picking up interesting events such as the one I just showed you. Since we're talking about exoplanets, I figured maybe the next couple of subjects will, or the final subjects will be on life on other objects or bodies, in this particular case, moons and planets. Last time I mentioned the sun as a possibility, although it's way out there. So, so there is a proposal for a mission to Enceladus in 2038, which would arrive in 2050. It's called the Orbit Lander. So it goes to Enceladus and orbits for 200 days to observe for observations and then finds a spot to land. Now, Enceladus during the Cassini mission was found to be ejecting water jets from these, what are called tiger stripes. And you can see some of the pictures online. It's pretty cool. It looks like a flying, a giant flying ball because of the jet spraying out at the bottom. And it detected traces of organic material within that water. And they have surmised that there's an underwater ocean that's being heated by the the core of the planet through tidal forces, tidal interactions with Saturn itself. So the nice thing about this particular moon is that it pretty much gives you almost direct access to the water coming out from inside of it. So it gives you the opportunity to measure the chemistry and to see if there is life there or signs of life. It's similar, if you recall, under the Earth's oceans, there's actually hydrothermal vents from which life lives from those vents, and there's no sunlight. So it's a completely different cycle, and it's based on the volcanic vents themselves. So I guess that's the possible hope here. So it's a good candidate to look for. There's also a proposed mission to Titan, the Dragonfly mission, for 2027 departure time. And the idea is that Titan basically has what they believe is a similar environment to Earth 3.5 billion years ago, and so has chemical building blocks for life. And so by going to Titan and exploring it will give us some sense of how life was perhaps formed on Earth. Titan's gravity is slightly less than the moon, and the atmosphere is quite thick, so thick that you could probably take a typical Leonardo da Vinci flapping wings and actually fly. So this vehicle here is, I think it's got 2 helicopter-like blades, and it hops from place to place. And a day on Titan is like 8 days on Earth, so once a day is the plan. So they would plan a hop and then tell it what to do, and then it would go ahead and do it because there's a long communication time, so it has to be carefully planned. And then it would land, and it has various instruments for checking out the chemistry on the surface, and cameras for, of course, visuals. Okay, so I found that interesting. Also, there's evidence of subsurface water oceans on Titan, but on the surface, the mountains and rocks are predominantly ice, and the seas and lakes and rivers are predominantly are methane. So, okay. So this last one I thought was interesting. It did come up recently. I think it was on the RASC national Facebook page. So this group discovered these phosphine chemicals in the upper atmosphere of Venus. There's a little typo there. And they surmised the only way that could be produced is through some biological process. There are processes that could produce the chemical, but it's under extreme conditions, and such as Jupiter. Jupiter has phosphine, and they surmise that's created within the atmosphere, deep in the atmosphere, and then churned up to the surface. But for the rocky planet of Venus, they've not found any mechanism for creating it abiologically. So the team has exhausted all alternative explanations in that regard. Now, so this is conjecture, but it's from their paper, and it's an interesting idea, but basically there's some upper cloud deck here. You have the altitude here in kilometers, and you have these, so this is sort of life cycle. You have these desiccated spores, an updraft, then the germination process starts and they come to life, and they live within these liquid droplets. There's nutrients in here, stuff for them to live. Those droplets then sort of grow and grow in size as they colonize, and then they become heavy and start sinking out of the habitable zone. And then the droplets start to evaporate because it's getting hotter as you go down into the atmosphere, and this triggers sporulation. And so you get these spores, and then the process just goes through this cycle. So that's the conjecture. Anyway, that's it for what's new. If there's any questions, please feel free to ask. I'm going to stop sharing so I can see. Yeah. How large is Titan? Good question. Does anyone know how large Titan is? Hello? Anyone out there?
I don't know.
Google's my friend. Hang on. I'd imagine it's comparable to the size of the moon if we give it, since the gravity is similar. Titan is 5,000 kilometers in diameter. And the moon is 3,400 kilometers in diameter. So the moon is probably slightly more dense than Titan because the gravity on the moon is slightly higher. Okay, so Titan's slightly bigger than our moon. Okay, I think that's the only question. There's stuff in the. Okay, that's just general chat. Okay, so now how do I give you back your control?
Just go to panelists, right click on the video camera and make me the host.
Panelists. I can't find panelists. Could be because I'm on a Mac.
It shouldn't really make much of a difference because you're still. Don't disable. That's kind of weird. Okay, so go to participants.
Oh wait, oh, who can share? Oh wait, what happens if I click all panelists?
Yeah, click on all panelists. I don't know why. Okay, try that.
Who can start sharing when someone else is? Okay. It seems I'm still host though.
But there should be a name on you and just right click it.
I'm meeting. I'm kind of lost here.
Okay.
You can talk if you can't share.
Down below, there should be sharing screen, chat, question, answer, and participants.
Oh, okay. There's a more.
Yeah.
Oh, participants. Okay.
And
okay. More. No, I'm under participants and I'm on my name. Now what?
okay, do you see the panelists now?
Yeah, I see the panel. I'm on the panelists. Yeah.
Right. Okay, great. Right click on the video. Right, a little video camera there next to the mic.
On the right-hand edge.
Yeah, I know. It won't let me do it.
Or not right click it, just use your single mouse, wherever the mouse button you have for a Mac.
As soon as I hover over it, it gets covered. Wait a minute, hang on. I have an idea. Here, is this it?
No. You're on your email address.
Oh, sorry, I feel like
Let's close it down and it'll give it away to somebody else.
Yeah. Okay, sorry about that. I don't know what happened. I guess we got to figure out more about Mac. Okay, don't you see the panelists there like you said before, right? Go to panelists.
Okay, I know that was participants.
There should be two, attendees and panelists.
I have panelists and attendees, yes.
Okay, go to panelists.
Oh, wait, hang on.
Oh, we got James. Okay, great.
Oh, here we go. I figured it out.
Okay,
You are now host.
okay, thank you. Okay, James.
Yeah, okay.
Okay. All right, Jay, well, we'll start with you, and are you able to take over the screen?
And you want me to become host, I take it.
You shouldn't have to. Like, I did enable all the videos, so I got to talk to Zoom about this. Like, when I set it up, I had everyone's videos, panelists set. Okay, so are you able to share your screen, or?
You tell me.
Got it. Okay, perfect.
There we go. Okay, October, November. The last warm or possibly warm month of the year before we have to cross our fingers and hope that December. So this is our last opportunity to do a few things without having snow on the ground. I don't see any coming in the next 10 or 15 days, but some of the models are getting a little quirky about it. Anyway, the sun, we had some sunspots. This is the first time in about 12 days or something like that we've had a sunspot. So, and these ones, as you can see where they're located in the diagram, they're a pretty low latitude. So the new cycle 25 sunspots, you can see the graph on the lower right there, cycle 25 officially started last December. You have to get at least almost a year past the bottom of the old cycle before they can make a commitment on when it ended and the new one started. You'll see the forecast for the new one. And I got to admit that these forecasts are notoriously inaccurate, but the new cycle is shown to have about the same amplitude as the one we just left, which was one of the lower ones in our history. So I figure that by 2023, the aurora will be coming back in so that you can probably count on seeing something once a week instead of once every couple of weeks, like we normally have at this time of the cycle. The sky, here's the skies at 10 p.m. tonight. And you can see we have 5 of the planets strung out along the ecliptic there. Saturn and Jupiter are low in the southwest and getting ready to set. This is for 10 o'clock. Mars is probably the brightest object in the sky. If you get out at 9 or 8, it'll be Jupiter, but by the time you get to 10, Jupiter's pretty low down and Mars is pretty high up. But we've had some conversations about Mars in the last few days because some of us have been able to get out to see it. And you'll notice the Milky Way in the summer part of the Milky Way is disappearing here in the west, and the winter part is coming up. And overhead, we have a relatively thin part of the Milky Way. Once you get overhead from Cygnus, it thins out a little bit, and then as you get down past Perseus and Origa, it starts to get a little more stuff in it. But it's still a pretty nice area to go viewing. You can see the clusters here in Perseus and Cassiopeia. They've got California Nebula down in here, which is often visible with binoculars under really dark skies. And then you in here in Origa, you've got 3 or 4 nice open clusters that can be observed. So this is all stuff that's coming up in the night. For the stuff that's going down, you've got a few of the goodies in the center of the Milky Way, but they don't last very long before they're gone for the night. I put this view up for what it would look like at 5 o'clock in the morning. It's starting to get a little bit light on the horizon by 5. But what I wanted to point out here about this, now we've seen that part of the Milky Way that was rising in the east has now moved across the sky somewhat. Here's Cassiopeia and Perseus and Origa that we talked about. But this is the plane of the Milky Way. It's the plane of our galaxy. So when you look out in this side, down toward Mars and where it says Earth's shadow and that, you're looking underneath the galaxy. You're looking out away from it. You're looking into parts of the universe and parts of the nearby part of outer space there where there is nothing blocking your view. And similarly, on the other side where the moon and Venus are, you're looking away from the Milky Way there. So all the stuff you like to look at in the Milky Way, all these little red bits that are all along here, they're not very common out in these areas. And because you're not blocked by the dust and gas of the Milky Way, when you look out in here, you look out in here, you end up being in a realm where you can see much farther into space and where the galaxies are. So even this 5 a.m. view, which is also very similar to the view that you'll have a month from now in the evening in November. But in this part, we have galaxy clusters in Ursa Major. We have galaxy clusters in Leo here. We have coming in behind Leo and not up at this time, galaxy clusters in Virgo. So this is the sort of galaxy time of year coming. Before it's gone, of course, we get the little goodies in Orion and in Taurus. But so it's a good time of year with no snow to sort of say goodbye to the summery Milky Way stuff and say hello to the galaxies as they're coming up in the east. And here we are just looking in the evening a month later, just to sort of show you that things have pushed along another 1/12 of the year in the sky. And we see now Mars and Uranus are high in the sky at 10 o'clock in the evening, but Saturn is just on the horizon and Jupiter's already set. We're going to be watching the Jupiter and Saturn over the next month until Christmas because they're going to be getting closer and closer, but they're also going to be moving closer and closer to the horizon. So when they reach their very, very close conjunction on the 24th of December, they'll be low down in the sky. So Mercury is on the east side of the sun. And if you stop and think about that, you realize that means it's visible in the evening, but it's low down. The ecliptic is very shallow angle at this time of year. So Mercury, even though it's on the northern hemisphere side of the sun, is very, very low and not a good view. Venus, if you've been up in the morning, it's pretty brilliant. It's getting a little higher every day at the moment. And as our hours of darkness increase, you'll be starting to see Venus when you get up at 7 in the morning, bright in the sky, because it'll be dark enough for it to really stand out. Mars, of course, is pretty obvious right now. If it's clear, you go and look out. It's just past its closest point to the Earth by 4 days. Up here in the corner, you see what Mars is on relative size on October 10 and on November 10. So it's going to be decreasing about 25%, 30% in size. So definitely at the time to go and see. I was out on Monday night, I guess it was, and used the 12-inch mead at Glenlee to have a look at Mars. And I turned that image around. This is sort of what it looked like when I was looking at it, except that it was probably that big in the eyepiece. It looked like a steer. You can see if you look at this, it's kind of got that Y shape, which is made up of Syrtis Major and the two features on the side here and the bright spot of Hellas. So it had quite a distinctive feature. I couldn't see the polar cap up here in the eyepiece, but when I put my camera on the telescope and switched it into live view, the details came out much more easily seen than through the eyepiece because there was a lot of turbulence that day. So you got about another month to get Mars when it's good and large. And because the rotational period of Mars is very similar to the Earth, it's only changes its aspect from night to night very, very slowly. We both rotate at almost 24 hours. Jupiter and Saturn, we've talked about, they're 7 degrees apart now. In the 10-day or 30 days from now, they'll be 4 degrees apart, and they'll be getting more and more prominent because of their close proximity. Our sunsets, shouldn't play with the center button on the mouse. The sunsets are getting earlier, so even though they're getting lower, we'll still be able to see them quite nicely. Setting at 11:38 and then 9 p.m. next month, and that would be 9 p.m. on daylight time, so it'll be heat in next month. Uranus is low down. It's visible if you want to go after it, but you want a dark sky if you're going to see it with binoculars or even with eyes. And you're much better off looking for Neptune if you've got a telescope, because it gets high up in the sky, but it won't be at its highest until you get into the early morning hours. We haven't got much in the way of pretty pictures. On the 22nd, we've got the moon in a triangle with Jupiter and Saturn. I forgot to switch on the shading on the moon on this one. This will actually be quite a narrow crescent moon with Saturn here and Jupiter here. So it should make for a nice little triangle. They're going to be about 6 degrees apart, so it's not really close, but it'll make a nice pairing or tripling in the sky. 29th, the moon moves underneath Mars, but now we're looking at a much fuller moon. Not very exciting, just that it's there, and you'll probably notice it in the sky. Something you might want to try is on the 13th in the afternoon, a few days from here. The moon and Venus will be very close together, but they'll be in the daylight sky. They're both set at 5:30, so you would have to sort of watch for them around 2 o'clock and anytime in the afternoon. And they should both be visible, especially with binoculars in the daylight sky. The only challenge you're going to have is actually finding them, because even the moon isn't all that easy to find when it's a crescent shape in the sky. But a good clear day ought to give you a chance to see both of them in the daylight without any trouble. Orionid meteor shower coming up in another 2 weeks. It's a shower that peaks very, very quickly, and it doesn't have a lot of meteors. Zenith hourly rate ZHR of 20, and that's what you would see in a really dark sky. The moon is in the first quarter. The nice thing about the Orionids is they tend to be relatively bright meteors, and it's leftover stuff from Halley's Comet, because Orion is sort of rising in the early evening. You're best after midnight when the constellation is up higher. You can see that the radiant here is sort of off the top left of Orion's shoulder. We have north and south Taurid meteor showers. They peak at different times. The south Taurid's on the 5th, the north Taurid's on the 12th. But you can see from the chart in the bottom, they're both pretty close together in their radiance. So you have the opportunity to see 2 showers, both with ZHRs of about 15, which should translate into 30 per hour. So at 30 per hour, you're starting to get a reasonably decent shower. These are both showers that come up and decay away very slowly, in contrast to the Orionids, which come and go in a 2-day period. So the south Taurids will reach their peak when the moon's bright, but in the north, it's a waning crescent, so you should get darkness through much of the night before the moon is up. Just if you can get enough photographs of it, you might even be able to show that there are 2 radiants in that pair. Let's see, October 31, and none of these hyperbolic full moons. This one's the smallest one of the year. I'm not sure we're going to hear anything in the media about this one. But if you ever wanted to take a picture of the biggest moon and the smallest moon this month, at the end of it would be the time to get your picture of the small moon, and then wait again in 6 months or so when you're on the opposite side of the lunar orbit and get a picture of the biggest moon of the year, and you can stick the 2 of them side by side if that sort of thing interests you. 1st of November, daylight time ends. November 4, oops. Full moon beside M35. Well, M35 is a nice cluster, but a full moon beside it doesn't really jog the gotta do it type attitude. And then November 12th, we have Venus and the crescent moon again. We're getting these things every month. If you're thinking these things are a little monotonous, Venus is there every month and the moon goes past it. And sometimes it hits it and sometimes it goes well north or south of it. Because you've got the southern Taurids, you might want to take your time with the Pleiades star cluster. You won't see it the same way in my picture here, but I've processed this one pretty heavily. But if you do go take a look at the Pleiades with a pair of binoculars, you will see around Merope and probably Alcyon, the two, you'll see this nebulosity around them. It's actually fairly easy to, and the Pleiades are pretty easy to find in the sky. I mean, I could say go to the bright star Aldebaran and look for it up here, but of course the Pleiades are much more prominent than the star. And you can check out M1 if you've got a hankering to see a supernova remnant up in here. So give yourself a little bit of chance with the Pleiades and a pair of binoculars when the Taurids are up and doing their meteor thing. Just for the record, here's the temperatures forecast for the next 10 days by the US model. And you can see we are in a slow decline of temperatures, sort of hovering daytimes above zero and night times on or below zero. And they show a little bit of precipitation supposedly happening right now, but doesn't seem to be. A little bit more on Sunday. But over here, all of these precipitation amounts they're showing are actually snow, except for the one that occurs in here in the middle of the day. So what this is saying is that we're going to get cold enough out toward the middle of the month to have snow. So we like a second opinion. So here's the Canadian model. And you can see the Canadian model keeps the temperatures a little higher. They get down below zero in the night times, but the lowest they get is in here, which is about a 7-degree high on the 16th. And you can see that they also have a lot more clear sky forecast, and except for a little stuff on Sunday, they have no other precipitation. So if you're an optimist, this is your forecast. And if you're a pessimist, this is your forecast. And there's the cat. Thank you.
All right, thank you, Jay. That's nice. Does anyone have any questions before we start with our main speaker? I don't think so. All right. So we'll have our next speaker, James Edgar. I think it was an excellent topic that he picked. It was both projection of the handbook and the journal. I think that would be a great topic to talk about, especially for some of our newer members who are not familiar with it. So, James, are you ready?
Yes, I'm ready.
All right, so want to proceed, please do.
Very good, thanks. I'm James Edgar. I'm the production manager of the RASC Journal and also the editor of the Observer's Handbook. A lot of what I have to say about the journal, Jay Anderson will be familiar with because he was the editor for quite a while. And I'll just begin with like a chronological discussion of what happens, how the journal gets put together. And then I'll go on to the handbook, which is totally different. On the journal side, it starts off with the editor sending out a notice to the columnists, telling them, jogging their memory that it's time to get their columns ready and sent in. This usually starts off about a week or so ahead of the deadline date, which is 2 months ahead of the production date. So say we're looking at the December journal, then right now we're 9 days into the production. And columns will already be at the editor, and we're starting to get she's starting to get the images together for the covers, the centerfolds, etc. The editor, if you're not familiar with her, is Nicole Mortellaro. She's science editor for the CBC in Toronto. If anybody is interested in looking at our schedule, it's published on the internet. You can find it at the RASC page at the editor's corner. Also, papers are submitted by interested writers. We have people that just submit their papers because they want to be published in the journal, or the editor may specifically ask somebody for a title that'll be published later. Anybody who sends in a article is asked to follow the journal style guide, which is published also on the editor's corner page. And then once submitted, an editor sends a paper, that's Nicole, sends a paper to one of the assistant editors for review. If it's a technical paper, a research paper, it's sent for peer review to the associate editor, Doug Hube, who's, I guess he'd be a professor emeritus in the University of Alberta in Edmonton, past president of the RASC, current honorary president. Following this review, the papers are uploaded to folders on a Dropbox page that we maintain for me to assemble, and I to do a further review to check for any spelling errors, style guide issues, that sort of thing. Making sure all of the URLs work, that the images that are cited in the paper are also submitted, that they're of sufficient resolution for printing, and the references in a paper follow the accepted style, which is the APA, the American Psychological Association style guide. And then all this activity takes about 3 or 4 weeks, sometimes longer. And the editor is collecting all the necessary cover and internal images for the centerfold, the inside covers, and so on. It takes a little while to get this all together. And then there's a team of 2 people who are paid, they're outside contractors. Fortunately for us, one of them is an RASC member, Michael Gatto, and he does pretty nice work. They do the layout. We send everything to them. Well, actually, we just tell them that the images and the columns are in the Dropbox folder, and they go to access it. And they get to work assembling the journal into what will become the proof copy. And they let us know, the production team, they let us know if there's images that are missing, or if they aren't of sufficiently high enough quality for use, that sort of thing. The other fellow, if you're not familiar with him, is Grant Tomchuk. He's an InDesign expert. He's not an RASC member. But the 2 of those, Michael Gatto and Grant Tomchuk, are the ones who put the journal together. And I think we have to say they do nice work. After the layout is complete, they advise us that there's a proof copy in one of the folders waiting for us to distribute to the proofreaders. And there are 6 of them. You can see their names in the masthead of the current journal. And they usually do proofreading for about a week. Each proofreader is assigned a number of pages to check, but they're also encouraged to check over the entire issue. The editor, Nicole, and myself, we check over the entire issue as well. And the submitting authors and columnists get a copy of their papers to check as well, so that they can see what the layout looks like. They can make any corrections to what their text was, that sort of thing. Once the proofreaders send back their comments for correction, all of the comments are assembled into a master PDF to send back to the layout team. And this is now about a month prior to the deadline date, sometimes a little later. It gets a little rushed if it's later, because the printing takes about a week. So the printer has to have the issue ready to go 2 to 3 weeks prior to the target date, which allows a week for packaging and mailing, which is done in a different house in Dartmouth, Nova Scotia. The schedule is quite loose, so adhering to it is sometimes a challenge, particularly for the printer, because he has to order the paper to be at the printing house on time. So he has to know how many copies are going to be made and how many pages there will be, and that sort of thing. The printing is done by a firm called Cancel in Dartmouth, Nova Scotia. So we have a pretty good rapport with this printer. They also print our observers' calendars, and they have done for many years. And the printer sends a final PDF layout to the production manager, me, for final approval. And once I check it over, make sure that everything is where it's supposed to be, that the centerfold pictures are in color and the covers are in color, that sort of thing. It's ready for final approval. Off they go. So the actual number of copies is determined by a person in the office in Toronto, Adela Zippi, and she figures out how many copies we'll need to send to people who have a paper subscription, how many they'll need for the office. There's usually 40 or 50 that are sent to the office itself, and that sort of thing. So she decides or collects all the information and sends it off to the printer in Dartmouth. And she also has assembled an address list for all the members who get a paper copy to send to the distribution house in Dartmouth as well. The production or the layout team sends me 2 PDFs, one high resolution, one low resolution for putting online. And there's a high resolution PDF is sent to a site called EBSCO, and they provide the journal to institutional subscribers, university libraries, that sort of thing. And there are somewhere in the neighborhood of 185 to 190 of those, mostly US subscribers. And I also send a notification to the Society office, to Adela again, to create a MailChimp announcement to the members, and then it's done. Until the next time, of course. And it's every 2 months we start up this process, and it's pretty well-oiled machine. The journals get out on time. They're always on or before the deadline date to be published online. There's another annual chore that I do, is to send out all of the journals and to the NASA Abstract Data System, the ADS, with an itemized text for each title, author, and page number for each issue. So I assemble all that information in December and send it off to the NASA ADS site. And that's it for the journal. It sounds pretty mundane, but it's an interesting process because it all occurs, like I say, over the course of about 2 months, and then we have maybe a week and a half or 2 week lull, and then it starts all over again. And I've been at this for 20 years. Getting over to the handbook, this is a totally different process, because the handbook editor is much more than just an editor. He or she does the editing, layout, manages the production, chooses the images, gathers all the data from the volunteer contributors from all over the world. And in the course of a few months, usually mid-May to mid-August, and the reason is because a lot of the contributors are academics, university profs, and that sort of thing. So we wait until university year has finished in early May or so before we ask them for anything. And when the contributors send all their information, all the data, the pictures, information on occultations and that sort of thing, then I plug all that information into the appropriate spot using InDesign. The entire file is pretty big. It's somewhere in the neighborhood of 23 gigabytes or megabytes. Some of the data requires tweaking. Some of it requires more tweaking than others. And it's interesting, Dave Chapman, the previous editor, made a comment once when I was talking to him. He said it would be probably very difficult to start up something like the handbook from scratch today. We got about 70 volunteer contributors all over the world. Nobody gets paid for this, and they do it joyfully. There's quite a few things that I have to do as the editor apart from the contributors. There's numerous bits that have to be done using various programs like Adobe InDesign, Illustrator, and Photoshop, Microsoft Word, and Excel. There are actually 52 bits. I'll just list a few of them so you can get a feel for what I mean. You have to, first of all, we have to decide the front cover and make sure the inside front cover is all correct information, get the title page done, the table of contents, and make sure that the list of contributors is up to date, because people come, people go, that sort of thing. And one of the last chores I do before sending the handbook to the printer is to do the editor's comments. I've targeted September the 15th as the printing date. So that's the date that I hand over the PDFs to the printer. So the editor's comments are usually on September 14th. And somewhere early in the year, we have to arrange for a guest editorial. And we've in the past had one of our honorary members write the editorials. Some of the people are responsive, some of them don't even answer the emails when we put out a request. So it's kind of like pulling hen's teeth. We have a very good one this year for the 2021 edition. It's Andrew Fracknoy, and I'm sure a lot of you will be familiar with him. Where was I here? Yes, we're talking about the things that I do, make sure that the reporting of discoveries is correct. People who want to just announce that they discovered a supernova or a new comet, that sort of thing, make sure that that is correct. And the physical elements, Roy Bishop looks after that pretty much. He's a professor of a retired professor in Nova Scotia, and many of you would be familiar with him as well. He's past editor of the handbook. He did it for 19 issues. We're looking at the minor planets, the orbital elements, the world map of time zones. I get from Her Majesty's Nautical Almanac office. They publish that each year, keeping it up to date. So sometime in mid-August, just before sending off to the printers, I download their PDF of the time zones map. And we figure out the mean sidereal time. We get this from the Astronomical Almanac. For the last couple of years, the United States Naval Observatory and the publications of the US Government Publications Office have reneged or fallen to the wayside. I'm not quite sure what's causing this, but we don't get the Astronomical Almanac until the Observer's Handbook has already gone to the printer. So fortunately, I have a couple of people that I can send emails to at the US Naval Observatory and to the Her Majesty's Almanac office, who will send me excerpts from the Astronomical Almanac so that we are not stuck. We get the Julian date. The current Julian date comes from the Astronomical Almanac, and make sure that the sky month by month introduction is correct, and I get the new moon dates, the moonrise and set information, and the moonrise and set diagrams, tables, the sunrise and sunset tables. I'm doing all this from information that I get from the US Naval Observatory. I also create the analemma diagram that changes each year, and the Mercury and Venus tables and graphs, and the Mars tables and that sort of thing. The Jupiter meridians, the Great Red Spot text, the Jupiter meridians table, the Jupiter's and Saturn size and magnitude table. The Uranus finder diagrams come from Ian Cameron in Winnipeg. I'm sure many of you are familiar with him. And the Ceres and Pluto information comes from Murray Paulson, who does the planets as well. We have to figure out a feature minor planet and get a finder chart arranged for that as well. And the stars and the constellations, the finding list of named stars, the 50 brightest stars, the calendar on the inside back cover. And all of those things are done by the editor in between everything else that's happening. So I've actually started on the 2022 handbook already so that I can just take it at a leisurely pace. And everything that I do, I feed onto the two proofreaders, Chris Malicki and Michelle Johns. And there's a software program that was produced by the US Naval Observatory called MICA. It's very helpful. It's a multi-year interactive computer almanac for the years 1800 to 2050. So it's essentially the tables and the information that you would be able to get out of the Astronomical Almanac in a computer form. So that's where the moonrise and set tables come from. The new moon dates are also generated from MICA. The same goes for the sun and rise and tables, sunrise and set tables. The cool little tip that Dave Chapman made, it allows me to use the previous 4th year's table because it's identical, plus or minus a minute. So as an example, when I'm working on the 2022 handbook, I can go back and get the sun tables from 2018 and copy them into the new book, and they work. Early in the year, I get the cover images figured out, who's going to supply them. And because the cover will be used for advertising from July onward, it's necessary to get those established pretty quickly. And happily, I've already got the covers for 2022 figured out. I also get the Society office early in the year, like in probably March or April next year. I'll get the Library and Archives Canada will supply the International Standard Book Number codes for each edition, the ISBN codes. So I got one for the standard edition, which a lot of people call the Canadian edition, but I call it the standard, and the USA edition. So they'll individually get different numbers. We usually get the observer's calendar number at the same time. And in about mid-April, I send out a request, excuse me, to Her Majesty's Naval Aeronautical Almanac Observatory and the U.S. Naval Observatory for excerpts from the Astronomical Almanac. So this all takes a bit of time. I've got to sign a license agreement with the UK because all of their data is copyrighted. So they have to sign a license each year for their information. So like I say, it takes a little bit of time to get all this arranged. And in mid-May, I put out a call to the 70 or so contributors to have their stuff to me by not later than mid-August, which gives about a month to catch up on any stragglers and make sure that everything is in place, let the proofreaders do a thorough job and make sure that if anything goes pear-shaped, I can get it corrected before sending it off to the printer. Most people meet that deadline, but not all. Right up till August 15th, I'm getting emails with additional information, and some of the contributors need a little extra prodding. I had one contributor for the 2020 handbook that his email address had changed and he hadn't told me. So I was sending emails off into the Ethernet and not getting any responses. And that's kind of scared me a little bit, but I finally did reach him by telephone and got the new email address. So that was helpful. And like I say, we need to have time to do a thorough job of the proofreading. And we can't really do the index until everything is finished either. So that's one of the last chores that has to be done, is to make sure that the index page numbers are correct. And it's not just for one book, it's for two. Me as the editor, I have complete control over everything that's used in the handbook, from the layout and design. And it's wonderful to have that much latitude, but it also means that I'm solely responsible for the nitty-gritty details of what occurs on each page, and to ensure all the headings have the same appearance, that the marginal tabs are in the right place, and so on. I'll draw your attention to the 2020 handbook. One of our sharp-eyed readers pointed out to me that the tab right here is lower than it should be. So starting on page 152 through to page 157 or 156. So we've corrected all that, of course, but these little gremlins creep into the program. I'm not quite sure where they come from because I didn't deliberately change those things, but there they are. When Randy Atwood, our previous executive director, asked me in 2017 about creating a USA edition, I said, sure, thinking it would simply be a matter of creating the standard edition and then US-ifying it. But it's much more complicated than that, as it turns out, because we have dedicated USA tables on page 205. We've got an abbreviated light pollution section to give room for the Astronomical League's 3-page article, plus all the examples given throughout are for USA cities instead of Canadian cities. And the USA table of contents and the index are different. The holidays and special dates at the back are different, and so on. So it actually means doing 2 handbooks at the same time, which is why we now have a proofreader specifically to do the USA edition. That's Michelle Johns. She's recently became a proofreader for the journal, and I enrolled her early in this year to be the handbook proofreader for the USA edition. And she's got a pretty sharp eye. She's very, very good at what she does. It's easy to make a mistake by, for instance, making a change on the standard edition and then getting sidetracked onto somebody else, and then forgetting to go and do the Canadian edition portion, or to do the USA edition, I mean. And that has happened. Unfortunately, the 2020 handbook has 2 major errors in it. I won't really get into them, but they're on the updates page on the internet. And we have 2 other proofreaders, Roy Bishop, who is the editorial consultant, creative consultant, if you like, and Bruce McCurdy, who does the Sky month by month, left-hand pages, the text. And he compares that to what Pat Kelly provides for the right-hand text, make sure that the dates match up, and that he's also correcting or proofreading to make sure that the meteor showers in the month by month are the same as the dates and times shown on page 254 that we get from the Peter Brown and his wife Margaret Campbell Brown. And the same for the eclipse data to make sure that the dates in the sky month by month match what we have in the eclipse section, and so on. And Roy Bishop, the creative consultant, if you look in the table of contents or in the contributors page in the handbook, you'll see that he's got a tremendous amount of information that he provides each year. And he helps with other contributors as well, and helps me with some difficult tasks. It generally makes tweaks to most of his contributions each year. And if you've never met the man, you should make an effort to delve into it a little bit. He's an RASC treasure. He's one of the first of the fellows of the RASC, in fact. And Betty Robinson, another one of the production team, is a professional copy editor. And for anybody who doesn't know, that's Randy Atwood's wife. And she takes the big text items and makes sure that they use proper English and good grammar, like the planets section, the eclipses section, and so on. She also generated the handbook style guide that we use internally. It's more complex than the journal's style guide because the handbook is truly a scientific publication. I think more scientific than the journal, anyways. And the big items that take a lot of the grunt work by me particularly are the eclipses section. Murray Paulson provides me the text. He gives me tables and graphs and all that sort of thing, and then I have to adapt them so that they'll fit into the handbook and make sure that we don't exceed the number of pages that are allotted for that section. And that's quite a challenge at times. Eclipses, the same thing. We get the information from Fred Espenak. So I've got tables, I've got diagrams, I've got the text, and it all has to be laid out in there. And similarly for the weather, eclipse weather from Jay Anderson. And occultations is a big chore. Each of the diagrams takes a little bit of tweaking before we can put it into the handbook. And finally, the brightest stars table. It's a massive undertaking by Tuomas Karmo, and he was a worker at the David Dunlap Observatory when Bob Garrison was the manager there. And Bob Garrison started this table, and Tuomas was his assistant. Now Tuomas is in charge of it with Chris Kerbali. He's at the Vatican Observatory, and Richard Gray is a professor in the Eastern USA. So you have to check out the expanded table that he's created for the brightest stars. He's done a tremendous amount of work, putting in a lot more information than we can possibly put into the handbook table. It's a work of art. Anyways, once everything is in place, I've got the 2 handbooks all figured out, created PDFs ready for the printer. And each of the covers has to be as a separate file because the handbook PDF doesn't include the back page or the inside covers. So there's a separate file that includes the front back cover, the spine, and the inside back and front cover. And that goes over to the Marquee Book Printing in Toronto. And they take it from there. They create proof copies for me to sign off on. And then it's off to the printing press. And the the 2021 handbook has been finished. We sent it to them on the 15th and it was delivered on Friday last, the 2nd. So they had it all done in 2 weeks. We have 11,000 copies made. 5,500 go to the Canadian and 5,500 go to the US. And we get orders from like Sky and Telescope, order somewhere in the neighborhood of 1,200 copies a year. Calmback, which is astronomy magazine, they order 1,000 or so. The Astronomical League orders about 600 or so. And then we get individual orders from lots of institutions in the States. They want 5 or 6 at a time, or even in an individual person will send an order to the society office to get a copy. And finally, it's good to check the updates page on the internet where the handbook errors are corrected. We strive for excellent, and we very often achieve it, but there's been no handbook in recent history that has been totally error-free. Even a person as sharp-eyed and astute as Roy Bishop, through 19 editions, never had one that was free of errors. These little gremlins do creep in. So, and that's it. That's my talk.
Yeah, thanks, James. That's great. So that's a lot of work. That's a lot of years of devotion to it. I can't believe it. And a lot of it is just volunteer work. That's pretty impressive. We do have one question here. Phillips has a question about it, and I think you might answer it. He asks, who decides what photo goes on the cover?
Yeah, that's me.
That's you.
That's me, yeah. In the, I was looking at Jay Anderson's image of the Pleiades, and if you have a look on the RASC website, you'll see that the front cover of the 2021 handbook is the Pleiades from Peter and Deborah Saravolum. Yeah, they created a massive image, it's like 52 megabytes. And so I sent an email to Deborah asking if we could use the image, and she was happily saying, yes, that's quite nice. So, and then I picked one for the back cover, which when you get your handbook, you'll see it's from the RASC Robotic Observatory, the robotic telescope where a meteorite zoomed past. So we got a meteor trail past the Cocoon Nebula. So it's pretty cool looking image. And yeah, it's pretty much my decision. I had Dan Falk send me an email asking if I was taking submissions for images, and he had one to supply. So that's going to be on the back cover of the 2022 handbook. Yeah. So essentially it's me who decides. I pick out something nice that I've seen and ask people if I can use it, or somebody will send a submission and I'll say yes or no. Does that answer the question? I think there's another question here.
Yeah.
Oh, that's a thank you from Philip.
All right. Okay. So if we have any more questions, wait, we have another one. No, that's about it for now. Okay, we're gonna end it right there. Okay, thank you, James. Thank you.
There is a question.
Oh, okay.
In the chat, someone asked, how are articles to the journal vetted?
There's 7 associate editors, assistant editors, that if the editor receives an article, she'll send it off to one of those people. Just a second here. I'm just looking for a recent journal so I can tell you. There we go. I found one. So if you look on the masthead, you'll see the assistant editors, Michael Allen, Martin Beach, Dave Chapman, Ralph Chu, Ralph Croning, Dave Garner, and Patrick Kelly are the assistant editors. So if Nicole Mortellero receives an article for submission, she'll review it herself. She'll send it off to one of those assistant editors to review and vet it, and then send it back to her. So they're looking for technical accuracy and that sort of thing. And if it's a research article, then Doug Hugh in Edmonton is the associate editor who does the research. He's the peer reviewer, in other words. So we have another question here. How many hours of work go into the handbook? Well, you could ask my wife that question. It's just too many. It's quite a bit. I would say probably I put in maybe 15 to 20 hours a week during the busy season, like through which would be July, August. That's the busiest time, and all of the different people are sending in things willing, you know, quite a few of them all coming at the same time. Through the rest of it, it's just, you know, maybe an hour or two a week doing the tables and getting all the information prepared for all the things that the editor has to look after. So, yeah, it is a masterpiece, Richard. Thank you for that.
All right, any more questions?
Right on.
Okay, I think that's it. Okay, thank you. Thank you, panelists, for showing up. Thank you, James. That was nice. That was very informative. Can't believe all the hard work, and it's all pretty much volunteer. That's
yes, indeed.
That's impressive. Okay, thanks for everyone. I'm going to end it right there. We'll continue on. We have this virtual Boston Pizza, James. I'll send you the invite. It's more like a meeting. But it's more open discussion for everyone. It's a great way to, you know, maintain your distance and still trying to socialize. It's a kind of a tradition that we have here at Winnipeg, where we go to Boston Pizza, but because it's COVID-19, you know, I had to do the virtual Boston Pizza. So anyways, thanks everyone. Happy Thanksgiving. So our next meeting will be November the 13th. All right. Okay. So thanks everyone. So we'll end it right there. All right. Good night.
Take care, everybody. Thanks. And thanks for inviting me, Brian.
Oh, you're welcome. All right. Good night, everyone.
Right.